Hi everyone, Mr. Chaffee here for today's lesson where we're going to be talking about some of the basics of functions and graphs. To get us started, we're going to need to go over a couple of vocab terms. First up, we have our domain, which is our set of all input values. Then we have our range, the set of all of our output values, and mapping, which we use to determine whether a relationship is a function. Now let's take a look at some examples and see how these terms are all related to one another. Number one, we have state the domain and range for the following relation. Is this relation a function? So with our domain and range here, I'm just going to use their first letters to represent both of them. And we know that they are both each sets of numbers. So we want to make sure we're making a pair of brackets for our domains and range here. Now let's see. For our domain, we're considering all of our input values, which are just going to be all of our x terms in each 5 of these points. So let's just go ahead and list out all of our x values. We have 2, 4, 3, 6, and it looks like that 2 repeats itself, so we don't need to include that again. Finish up with my bracket there. Likewise, we have our range, which is going to be all of our outputs, all of our y values here. So let's just list out each of our y terms. We have -3, 6, -1, looks like 6 repeats itself, and 3. So we don't need to list out any repeats there again. We have our 4 terms in our domain and our 4 points in our range. Now we want to figure out if this relation is a function. Well, to do so, we need to think about all of the points in our input. To be a function, any point or value that goes into our input must be mapped to a single point within our domain or within our range. So anything that enters in with our domain must be mapped to a single point as an output in our range. Which, in other words, that says if we have any points of our x values here that the same point goes to 2 different values, that would break our rule for being a function, as we need any given point to only be mapped to a single point within our output. Which means the 2 points here where we have an x term of 2, well, in one case, when we have an x of 2, that input is going to -3. In other times, that input is going to +3. So that single input of +2 has 2 separate outputs that it can go to, meaning this is not a function. Now let's try number 2. Same thing, we're asked to state the domain and range for the following relation and then determine whether or not it is a function. So this time around, let's right off the bat just list out our domain and range values. So we have our -3, -2, -1, 0, 1, and 2, giving us all 6 of our points for our domain. Now for our range, we've got 5, 5, 5, 5, 5. Looks like everything repeats itself here. So I'm not going to list out a bunch of 5s. We don't need to repeat them anytime. It becomes redundant. So we just need our single 5 here. Now, earlier we were looking at whether each one of our input points were mapped to a single output point, which means anytime we have the same value for our x pop up, we want to make sure it's going to the same location. Well, here, it looks like we don't have any repeats between our x values. So we have all unique x values from term to term, but it looks like all of those x values go to the single point of 5 within our range. So what that says is that no matter the input that we're given, all of our inputs will appear to go to the same output. But that's also okay. We can have our inputs go to the same output as long as all of those inputs have one key destination in mind, which in this case they still do. So this is a function here. Let's use some pictorial representations to get a little bit of a better idea of what I just said. So let's look and determine whether or not these 3 are functions or not. So number 3, we're looking for each point in our input here, and we want to see that each of these single points has one single location that it's being directed to, which it looks like they do. They all have one arrow coming out of them, meaning that it is a one-to-one relationship here. So we've got each point is being mapped to one area in our range, giving us a function for our first one. Okay, number 4 here is pretty similar to the number 2 we had previously looked at, where all of our points in our domain are being mapped to the same point in our range, but each single point in the domain only has one pathway for it to be outputted into a range value. So that is exactly what we want to do if we want to have a function here. So we can again confirm that this one is a function. Now, number 5, we have all of these first couple of points go directly across to one single point in our range. However, with number 1 in our domain here, we can have 1 can go to 0 or 15. So this point has 2 different pathway options for its output, which is very similar to the first problem that we looked at where that 2 had 2 different outcomes. So since we have 2 different outcomes for one of our input values here, we know that this one is not a function. Okay, with 6, we're asked what are the domain and range of each of the relationships represented by the points plotted in the graphs below. Okay, so with our graphs, it's actually really nice and easy. We have a quick test to help us determine whether or not something is a function, which we refer to as the vertical line test. And all the vertical line test does is say, as long as there's no place in our graph such that we can draw a vertical line and we will intersect more than 2 points on our line or on our graph, we have a function. So in this first graph, there's nowhere that I can draw a straight vertical line that I will be intersecting more than 1 point on our graph, which means for every input that we have, we only have one output, giving us a function. Similarly, in letter B, there's nowhere I can draw a vertical line that I will intersect more than 1 point of our original line. So for every one input, we again have one output, giving us a function here. C is really tricky to approach at first because it appears that we can just draw a vertical line right here and we will intersect our graph twice. However, if we look a little more closely, we can see that both of these dots are open dots, which means that neither of them is actually included within the graph. So if we draw a vertical line right there, we're actually not including any point on our graph. So that was our one trouble spot within our graph. Anywhere else we draw a vertical line, we should be good. So letter C is actually also a function. So all 3 of these passed our vertical line test. Maybe that'll pop up later for us. We can see some examples where we have a failure there. But now let's move on, and we are trying to select an equation that represents functions where the range decreases as the domain increases. So as our x values get bigger, we want our y values to get smaller. So let's go through, and I'm just going to circle the ones that are true for this statement. So anytime the statement is true, we can circle it, otherwise I'll give it an X. So in letter A, we're starting off with a smaller y value of -7 when our x is 0, but then as x continues to get bigger and bigger, we're adding that value of x to y. So we're adding a positive x value to y, which means that our y would also continue to get bigger as our x increases. So letter A, we can say is not true. That's the exact opposite of our desired relationship. Letter B, we're starting off with that -4 when our x is 0, but then it's the same thing. We have a positive 5x here, so as our x gets bigger, our y is also going to grow in relationship to that x. So they both will increase together. But why don't you see if you can consider letters C and D on your own and see if you can determine how they are related to one another. And once you think you've done so, you can unpause the video and we'll go over things together. Okay, with letter C, we have the same idea where we have starting off with a -y here, and we're adding a positive x term, so slowly as x increases, y is going to increase as well, which leaves us with D. We're starting off with a positive y term, and as x gets bigger and bigger and bigger, we're subtracting away part of that value to give us our y, so our y will slowly become negative as x becomes increasingly largely positive. So D is our right final choice there. Alright, number 2 is asking us to look at the following table, which shows output values for the function y is equal to negative x plus 4, and then determine which possible set of domains would work for this table here. So we already are given our 5 outputs, and we have our equation. So in order to get our input values or our domain values, all we need to do is plug in our outputs for y and then solve for our x terms in each of these cases. So we can start off and say 2 is equal to negative x plus 4. Well, this one's easy. We can subtract 4 from both sides. And then we'll divide by negative 1. And we'll get x is equal to 2. So whenever we have x is equal to 2, we get an output of 2. So that's our first point in our domain, which I'll list down here. So now we know we can get rid of c because 2 is going to come up there at least once. Let's try another one. So we'll say 0 is equal to negative x plus 4. Now let's subtract that negative 4 from both sides. Divide by negative 1 here. And we'll get 4 is equal to x. So now we have 2 and 4, which it looks like we can get rid of letter choice A. And move over here, we'll do negative 3 is equal to negative x plus 4. Let's subtract our 4 again. We'll get negative 7 is equal to negative x, and divide by our negative 1s. We'll get 7 is equal to x, which looks like that still leaves us with 2 choices here. So let's keep moving our way through. Do my next one over here. So we have negative 4 is equal to negative x plus 4. Subtract our 4s. We'll get negative 8 is equal to negative x. Divide by our negative 1 again and get 8 is equal to x. So now that looks like that eliminates all of our choices but D. So D is going to be our correct final domain choice here. All of these values correspond to some input that we can plug in and get these 5 values for our outputs.